Hallo Leute, it is tendedtadpolebiz here, and people are bad at understanding things. Especially when it comes to science, I see a lot of misinformation going all over the place, and being a biology major myself, I figured I would lend my expertise to help clear things up for the internet. And one of the things that I see that people seem to have no idea about is something called evolution. And given that I am currently learning more about it than most people are, I figured I would do what I could to explain it in the universal language of Minecraft. So I hope y'all can get something out of this, and I hope y'all enjoy. So the first and most obvious question you're probably wondering about evolution is, what is evolution? The most concise answer you'll get is, it's a change in a population over time. Now, does that mean if you have one sheep here that's born with white wool, and over the course of its lifetime it becomes red, is that evolution? Well, no, because that's just one individual. The same way your hair color may change over time, or you may develop freckles, or different changes in your own body happen, those are mutations, those are not actually evolution. Evolution would be if, let's say we take that same one sheep, and we had one sheep randomly mutate to where it had red wool in an already white population. That's a mutation in this population. However, if over time, the offspring of these sheep began to have more and more red wool because, let's say it was favored, or it was easier for them to live, or something like that. This is an example of evolution because it's a trait evolving over time to be adapted more, and usually it means that it suits the environment better. So a change in a population over time. That is what evolution is. Now, it's also important to note that when we're looking at just one population, this is something called microevolution. This is usually what most people are taught in school because it's the most simple to look at. If you have one simplistic trait that changes over time, that's called microevolution. However, we're often told that one organism can evolve into a bunch of different organisms. So like all mammals, in this case I have mostly mammals, are related by a common ancestor. Well, that's called macroevolution. The idea behind macroevolution follows the exact same way as microevolution. So usually it starts within just a population. Often there's some sort of physical barrier between them, like say when a mountain goes up or when Pangea split, in which they will begin to get a little bit more and more different as more and more generations go on. Well, over thousands of years, these changes pile up and eventually they are not the same species and they can't interbreed. That's how species differentiate and separate from one another. But tadpole, you're probably wondering, aren't mutations very rare, and aren't they usually pretty bad? Well, yes, the answer to both of those is yes. The majority of mutations we have are either neutral or usually are non-beneficial. So like cancer, for example. Any organism that gets cancer usually does not fare so well. Humans are a little bit different because we have modern medicine, but it's still not a good thing. And a lot of the times, mutations are not that great. A good chunk of the time, they're neutral. They don't really change much, so we don't notice them. However, for a select few of them, they can have a good benefit. So in this example, we just had them going from white to a couple of them going to red. The reasoning for this, though, is because mutation itself cannot simply make all of these white ones turn into red ones over time. To answer that, we have something called natural selection. So in this example, we have a different population of sheep. In this example, half of them are red, half of them are blue. Leading up to this point, there was no preference to whether they would be red or blue at birth. But, let's say I came along with my little doggo here, and my dog decided he was hungry. But when he looked at these sheep, he was colorblind. He was blue colorblind, and he could not see the blue sheep. However, the red sheep were very obvious to him. So in this example, he would eat 2 of the red sheep. Now, for the most part, that wouldn't normally mean anything, but over time, when this happens, you will notice, and especially if it's in a very small population like this, we went from it being 50-50 red to blue, to now it's 3/8 red and 5/8 blue. Especially in small populations, this will have rapid changes. So in their immediate offspring, you will see about 40% of them are now red, and 60% are blue. Now that's with one generation. Most of the time, when you have an environmental change, it's going to be very sudden, it may last quite a while, and it often has lasting impact. So this change to 60% is likely going to extrapolate out And the more generations that go on, the fewer and fewer red individuals you are going to see because, in this case, the dog is going to continue to eat them. So, basically what this means is this is an example of natural selection. Nature will select a certain version or a certain phenotype of that specific trait, in this case, the color, that it sees as preferential. Now, I say it, but natural selection is just a force. It's the idea that if something is favorable, it is going to win more often and is going to lead to the survivorship of that individual more often. So being blue in this example is going to lead to more of them surviving, more of them reproducing, and that trait being passed down. That's the basic idea of natural selection. So while this model works pretty well for showing natural selection, that's not how everything works in nature. Obviously, there are some random events that will just randomly do things in ways that we cannot predict. So while we may be able to predict that the blue sheep are going to be able to survive better than the red sheep, what if there was some sort of storm or something came in that randomly killed off a significant portion of the population? So in this example, let's say, some tornado came through and all 4 of the red sheep were hiding in a cave with one of the blue sheep. Sadly, the other blue sheep all died. Now that's something that happens in nature, and it happens not terribly frequently, but it's a common occurrence. In this example, while it was preferential to be a blue sheep, right now they are outnumbered significantly. Now they make up only 20% of the population, when before they were 60% of the population. This is called genetic bottlenecking. Some sort of outside force has a significant decrease in the population, causing the allele frequencies of those that survive to jump up. So while before the red sheep were only 40% of the population, because so many blue sheep were killed off, they're now 80% of the population. And when they have offspring, instead of there only being 6 red sheep to 4 blue ones, now there's 8 to every 2. Now, as time goes on, natural selection can still play a role, but for this one generation, there was a significant spike in the red allele. This is called genetic bottlenecking. You will also see the same effect if, for instance, those same 5 sheep went off and, let's say instead of a storm, they just decided they were going to wander off and start their own population. You would get the same effect in this instance. While obviously, a bunch of them didn't die off, you would still have those 5 starting a new population, and the next generation would look the exact same way. And that's called the founder's effect. So genetic bottlenecking and the founder effect, different causes, but pretty similar results. And last but not least, I could not get through a biology video without at least including a Punnett square somewhere. So I'll try to make this brief because I know most of you probably don't like them. For those of you who don't know, a Punnett square is basically just like a physical mathematical interpretation of how different alleles are passed on. So in this instance, you have a red sheep that has both of its alleles have the red gene, or both of its genes have the red allele, and the same with the blue, except with blue. When they have offspring, this one will always pass down the red allele, and this one will always pass down the blue allele. So in this instance, red and blue, you get purple. That's the basics of how that would work, with 2 homozygous individual, homozygous meaning the same allele. Well, their offspring are all heterozygous, having one of both. So if you take those offspring, and in this case, the blue has the blue, red has the red, if the parents are the same heterozygous offspring, you can use that to predict what the next generation will look like. So these will be the grandchildren of those original homozygous individuals. Half the time, each one of them is going to pass on a blue allele. That means 1/4 of their offspring we should expect to be blue. You would then get the same way with the red. 1/4 of the offspring should be red, because half of the time for each of these, you will get the red allele. 1/2 times 1/2 is 1/4. The remainder of those are in which one gives the blue and one gives the red. You will get the same purple as their parents look. So in general, that's how Punnett squares work. I hope that makes sense. So hopefully that helped clear up any misconceptions you may have had about evolution. I know most people have a generally good idea on it. I just know that, especially when I see things talking about it, both from scientific and non-scientific sources, people seem to not understand things that I thought were pretty basic. But with that being said, if you have any other questions about evolution, like I said, I'm a biology major. I can try and explain it in the comments below. I just thought it would be fun to sort of give you guys an insight of the type of stuff that I do on a day-to-day, because, you know, shocker, I don't play Minecraft constantly. So, yeah, if you guys have any questions, you can leave those in the comments below. If you would like me to explain other science things in terms of Minecraft, I would be happy to, but as of now, I'm expecting this to sort of be a one-off thing just because I was bored. But, yeah, I hope you guys enjoyed, and I'll catch you guys next time. Tschüss, Kinder.